Okay. Alright, today and Friday we're going to finish up the unit. And then we're going to start reviewing, and you're going to have a class next Wednesday or Thursday. We'll know for sure on Monday, so start planning ahead for that, okay? Now, who remembers the very last thing we were talking about yesterday? Do you remember? Polar form. We were talking about polar form. And what I didn't tell you is polar form is also sometimes called trigonometric form. So remember yesterday, okay, we got polar form, and then we have complex form, which is also called rectangular form, which is also called Cartesian form, right? So we have all of these different names that mean the same thing. Complex form is x plus yi. Who remembers what polar form is, or trigonometric form? What is it? R cosine theta plus sine theta. And I told you if you wanted to, you could abbreviate that like this, right? Cosine, I sine, squished up there, okay? So, we need to be able to switch back and forth from form to form, but we already know how to do that because you did it actually on your quiz here, at least a little piece of it, because you took this ordered pair, which was an x and a y, and you found r. So let's practice one of each of these going both ways. You already have this skill, and then I'm going to show you what we're going to do with it. Okay, so let's change -1 plus root 3i into trigonometric form, which is the same as polar form. So stop for a moment. What are these? What are these two numbers? X and y. And what are we looking for? R and theta. So I'm going to draw a picture of my x and y. And then this will be r, right? What will that be?
2.
That was going to be 2.
We know what type of triangle that is.
And actually, this one you should be able to do without a calculator. This is a 60-degree angle, but be careful. Theta is not 60.
It's 120.
Theta is 120. So our trigonometric form, longhand, would be this. But I think I'm going to quit writing them longhand, and I'm just going to use the shorthand if that's okay with you. That would be the answer to the question. Is everybody okay with that? All right. Now, let's go the other way. Let's suppose we want to change 3 CIS 150 into complex form, or rectangular form, or Cartesian form. Okay. So what are these? What are these things right here? What's 3 and 150? What's that?
Radius.
That's r and theta. What am I looking for? X and y. So I am shooting for this. Now, who remembers our very special equation to find x? How do we find, if we want x, how can we always find x? R cosine theta. So what is x going to equal? 3 cosine 150? And what is y going to equal? 3 sine 150. These are no-brainers. Now, 150 is one of our special angles. I know you could take out your calculator and type it in. And if it were 140, that's exactly what I would be doing. But let's review how we handle special angles, 150. So I'm going to draw 150 degrees. How big is my reference angle for this 150? That's a 30. and I know across from the 30 is 1, and then I stop and say, okay, are any of those negative? Are there any negatives in that situation? Root 3 is negative, right? And then I can plug in my numbers. So x is 3 cosine 150, so the cosine of 150 would be adjacent over hypotenuse, negative root 3 over 2. And the sine of 150 would be 1/2. So without a calculator, it looks like my number is negative 3 root 3 over 2 plus, 3/2 on. If you type that in on your calculator, you're going to get decimals. You're not going to get those fractions. You're going to get decimals. But on your quest, I have asked you to be exact when possible. These are exact answers. So when can we be exact? When the angles are special.
How come you're allowed to use 2 as the radius in the picture and the equation is 3? Or is that?
Okay, I'm allowed to do that. This is a picture of just the angle to allow me to find the sine and cosine. The 3 gets taken care of right here. Okay, that's a good question. But my focus was right here, so I'm ignoring the 3. I'm just finding the cosine of 150, and then I will multiply it by 3. All right, so now what are we going to do with this? Well, we are going to start by taking a look at a couple of numbers. I'm using the same notation your book does. They call these numbers names, and they call them Z sub 1 and Z sub 2, so I will too. Z sub 1 is, let's say, 3 CIS 100, and Z sub 2 is 2 CIS 80. Okay? Now we're going to do several things with these numbers. We're going to multiply them together. We're going to divide them. We're going to do whatever that means. And we're going to do whatever that means. Now, I'm going to tell you the answer to this question, and then I want you to tell me how I did it. It's really interesting. It's really easy and it's just really easy. The answer to this question, I'm going to multiply these two numbers together, okay? These are the two numbers now I'm going to multiply. And the answer is this. Now, how did that happen? How did I get that, Dan?
You multiplied the front numbers and added the back two.
Exactly. So I multiplied, what are these numbers? These are my R's, my radii. So I multiply my radii, and then I add my angles. Now, how do you think we're going to divide? We're going to divide the radii and then subtract the angles. There you go. So if you want to multiply numbers in polar form, this is polar form. If you want to multiply numbers in polar form, we simply multiply the r's and we add the angles. If you want to divide them, you divide the r's and subtract the angles. Now there is one little kink we have to talk about here. If that had been the upside down, which it could be, we could divide that way. We're going to divide our r's, which would give us 2/3, right? But what angle would it give me? Negative 340. Yes, in polar form, you are never allowed to have a negative angle. So instead of negative 20, somebody out here said it, instead of negative 20, we would have to translate that into 340. If you have a negative angle, you must make it positive. And how do we make it positive? We simply add 360 to it, right? That's how we make it positive. All right, so quick, I know we went through this very fast, but let's go through it. Let's make sure everybody's got it. To multiply numbers in polar form, what do? Multiply the r's, add the angles. To divide them, you divide the r's and subtract the angles. If the angle comes out negative, add 360 to make it positive. Okay? Now, this notation. This is the notation for conjugate. Now, you've all heard that word before. Let's think of a complex number. 2 plus 3i. What is its conjugate? What's the conjugate?
What do you multiply by?
Yeah, when you rationalize, you multiply by the conjugate. What would you multiply by? If this were in the denominator, you'd be multiplying by 2 minus 3i. So if this is the number, then the conjugate is 2 minus 3i. Now, how does that work when you're in polar form, though? Well, let's look at these two numbers for a second. 2 plus 3i would look like this. Would you agree with me? And the radius would be root 13, and that angle is whatever it is. I'd have to look it up on my calculator. What does the conjugate look like? Well, it looks like this, doesn't it? What's its radius? Still root 13. And how about this angle? If that angle was theta, what would this angle be? Same thing, only negative. So the conjugate has the same r value, but the negative theta value. So the conjugate of z sub 1 would be 3 cis negative 100. Instead of going positive 100, we're going negative 100. Does that make sense to you? But of course, what did we just talk about? You can't have a negative there, so we're going to have to rewrite that as 260. And that is the conjugate of the number. So if I said, let's find the conjugate of z sub 2, has the same radius, but the opposite angle. Everybody still following along? Then we'll make our adjustment, so that would be 2 cis 280. So that's the answer. That's the answer to that one. So everybody got how to handle the conjugate? Same r, negative angle. Because when you draw the conjugate, you go the opposite direction. What's that mean? What's that notation mean? You already know that. That means, well, it looks like absolute value, but what does it mean to us? It means magnitude or length. It means magnitude or length. I want you to think about this number right here. If I drew a picture of that number, how long would it be? 2. 2. Isn't the length of the number just the radius, kids?
Indeed.
So if you want to know the magnitude or the length of z sub 2, it is just 2. What's the magnitude or the length of z sub 1? 3. Okay. So now, we're going to take one of these numbers. I'll just use 3 cis 100. And we're going to raise it to the 4th power. Now, what does raising to the 4th power mean? Means timesing it by itself 4 times. So basically, we're going to times this thing 4 times. Now, do we know how to multiply numbers in polar form?
No.
Oh yeah, we do. We just talked about it. Z sub 1 times Z sub 2. How do we multiply two numbers in polar form? What do? We multiply the r's and we add the angles. Well, we got 4 of them here. So here we go. Multiplying the r's is going to give me what? 81. And adding the angles is going to give me 400. Now we have a problem. See that angle right there? The rules are real strict. That angle can't be negative. We've already talked about that. It also can't be bigger than 360. So what are we going to do? We have to fix that. It's too big. We can't leave that down there. We're going to fix it. What's it going to be?
40.
It's going to be 40. And it's 40 because we are subtracting 360. Now, the next time I do this problem, I am not writing this out 4 times. Because basically what happened here? Basically, didn't we just take 3 to the 4th power? And then we took 100 times 4? That is one of the most famous theorems in mathematics, and you just discovered it yourself. It's called DeMoivre's theorem. And DeMoivre's theorem says exactly what you just said. If you have a number in polar form that you are raising to a power, all you have to do is take the radius to the power and take the angle times the power. So, if I have 2 CIS10 and I want to raise it to the 8th power, you can do this in the snap of a finger. What would 2 CIS10 to the 8th power be? 2 to the 8th power. Anybody know what that is offhand? 256. And then CIS 80. Done. Done. Wow, that's pretty easy. All right, so it gets a little harder, as you might imagine. What happens if I say, let's find -1 minus root 3i to the 6th power? Oh, there we go. Step 1 is we got to change the number into polar form. Because DeMoivre, which is so simple, is only going to work if the number's in polar form, right? So we're going to change this into polar form. So what are these two numbers? These are x and y. I need to figure out r and theta. So here we go. I'll draw a picture. What's my r? 2. Now, you ought to be able, again, you ought to be able to look at this and tell me how big this angle is right here.
60.
That's a 60. Do not put 60 here. What goes here?
210.
No, not 210.
240.
240. Why 240? 180 plus 60. Right? Now, this isn't the answer to the question. Don't get excited. This is the number that we now have to raise to the 6th power. You with me? All right, so how does DeMoivre work now? We got our number in polar form. We're going to raise it to the 6th power. Here we go. 2 to the 6th. 240 times 6. Is that 1440? Okay, so one more time. How does DeMoivre work? You take your radius to the power, you take your angle times the power. Now, are you going to put this in the answer blank? No, because it's the right answer. You've done everything right, but that angle is
That's just 36.
too big. So what does that shrink down to? All the way down to 0, doesn't it? Start taking out 360s, and you get all the way down to 0.
Wait, if you have to take it down to 0, then why wouldn't you just leave it at 360?
That your theta has to be between 0 and 360, and 360 is not included. 0 is the smallest angle. 360 is the same as 0, but we use the smallest angle we can, so we're going to use 0. It is the same as 360, which is the same as 1440 and 720 and all those others, but we're going to use 0. All right, so this was our original problem, right? If you had done that, if you didn't do this, if you FOILed that out, this would take a long time, wouldn't it? This is a big problem. But by changing it into polar form, we got our answer pretty quickly. Now here's the problem though. What form was that given in? That problem was originally given in what form? Complex or rectangular or Cartesian form. What form is this? Okay, so we need to change it back. In order to do the problem, we change it into polar form. And that's how you want to do it, because it's so much faster. But then, you got to switch it back to the form that it was originally in. So, what is 64? That's your R, and this is your theta. So what are we looking for now? We're looking for x and y. So, how do we find x and y? X equals 64 cosine 0, and y equals 64 sine 0. Now, 0, think of your handy dandy unit circle. Isn't that 0 right there? What are the coordinates of that point? 1, 0. Cosine is 1. And sine is 0. So what does x equal? 64. What does y equal?
Root I.
60, or y just equals 0, doesn't it? So x plus yi will be 64 plus 0i.
Now we done.
And that is the answer to the question. So who would have thunk it, folks? But if you took that and FOILed it out 6 times, the answer would just work out to be 64. But I'll let you do that on your own time, because it's going to take you a half hour. All right, let's try one more, and then I'll be done. Let's raise negative 2 root 2, no, 2 root 2 minus 2 root 2i. Let's raise it to the 5th power. All right, so take a deep breath. All right, how do we start? What do we want to do first? Get it into polar form, which means find r and theta. So I'll draw a picture of this. Let's talk theta for a quick minute. See how these two match?
8. Oh, 45.
What's that tell you about theta?
45.
That's got to be a 45 right there. Now, that doesn't mean my angle is actually 45, but that angle is 45, right?
Mm-hmm.
Okay, what about r? What do you get when you square this?
8.
8. What do you get when you square that? 8. 8 and 8 is 16, and the square root of 16 is 4. So my radius is 4. So my number is 4 CIS what? Be careful.
315.
315. Everybody got it? Now that is not the answer. This is the number that we are going to raise to the 5th power. Correct? Okay, so how does that work again? 4 to the 5th? I have no idea what that is.
1024.
1024. And then that's 4 to the 5th. And then what do I do? 315 times 5, which is 1575.
It's gonna be 135.
Which is way too big.
It'll be 130.
So we start taking out revolutions, and Dan says that comes down to 135. Everybody okay with that? Now, if the directions say leave your answer in polar form, you're done, right? That's the answer right there. But almost always, if the problem starts out in rectangular form, you will be expected to answer it in rectangular form, which means you have to do what now? Find x and y. So here's our number,
Well, we can't really do much.
and we need to find x and y. This is the polar form of the answer. This is the answer to the question, but it's in polar form. So now we want the rectangular form. So x will be 1024 cosine 135, and y is 1024 sine 135. Everybody okay with that?
45.
Now, I know you can type that in on your calculator, but again, 135 is special. I'm trying to practice these with you today. Review this. 135 degrees has a reference angle of how much?
45.
45. 1 root 2, right? Any negatives in there? That x1? So now I'm going to type in, or I'm going to put in the cosine of 135. What's the cosine of 135? Negative root 2 over 2. What's the sine of 135? Positive root 2 over 2. So the 2 will cancel in. It looks like I get negative 512 root 2. So negative 512 root 2 plus 512 root 2i is the complex form of the answer. Now again, if I had not had a special angle, you would be typing that in on your calculator and getting decimals. X equals our cosine, y equals our sine. You would just get decimals there. But I'm asking you to be exact when possible. And if the angle is special, it's possible to be exact. We can't lose that skill. We have to keep up with that. All right, everybody okay with that? All right, tomorrow or Friday, we will learn how to take roots of these numbers, and then we'll be done with this little unit, okay? But that's enough for today. So you've got 6 minutes. You can start your homework.